Hi, my name is George. I'm a curriculum manager at DataCamp, and I use Git on a daily basis for version control in my projects. In this course, we'll discover the benefits of version control and why Git is so popular for this. Let's start by defining version control, which is a group of systems and processes to manage changes made to documents, programs, and directories. Version control is helpful for anything and directories. Version control is helpful for anything that changes over time or needs to be shared, such as code and data. In this course, we'll focus on version control such as code and data. In this course, we'll focus on version control for code. Version control allows us to track files in different states, combine different versions, identify a particular version of a file, and revert changes. So why should we particular version of a file and revert changes? So why should we care about version control for our software or data projects? Well, a project without version control is like cooking without a recipe. It'll be difficult to remember how to produce the same results again. Imagine we work for an e-commerce company and release a new feature on our website that recommends products to customers. However, there is a bug in our code and the website stops working. With version control, we can easily revert our website to a previous working version, then work separately to identify the issue before safely re-releasing the new feature. So, how do we perform version control? One popular program for version control is called Git. Git is open source and scalable to easily track everything from small solo projects to complex collaborative efforts with large teams. A key benefit of Git is that it stores everything, so nothing is ever lost. A key benefit of projects source and scalable. To easily track everything from small solo projects to complex collaborative efforts with large teams. A key benefit of Git is that it stores everything, so nothing is ever lost. It allows us to compare the contents of files at different times. We can even examine what changes have been made, who made them, and when. Critically, if our software has issues, we can revert to a previous version that is known to work correctly. A common method to use Git is via the shell, also known as the terminal. The shell is a program for executing commands. Before we use Git, we'll run through some shell commands that will often as the can revert to a previous version that is known to work correctly. A common method to use Git is via the shell, also known as the terminal. The shell is a program for executing commands. Before we use Git, we'll run through some shell commands that will often be used in our version control workflow, such as previewing and inspecting files or directories. Note that a directory is often referred to on a computer as a folder. To see our location, we can execute pwd, which prints prints the current working directory. Here, we're in the Documents directory. The current working directory. Here, we're in the Documents directory of a user called REPL. We can use the ls command to see what is in our current directory. The output returns a list of all files and directories. There is a directory called archive and free CSV files. If we need to change directory, we can execute cd, followed by the directory we want to move into. Here, we navigate to the archive directory. Rechecking our location confirms we have successfully moved. Let's learn our first git command. Different versions of software have different functionality, and Git is no exception. We can check which version of Git we have installed by typing git -- version. In the shell. Now, let's check our understanding of version control. Let's start working with Git. Throughout the course, we'll work on a project about mental health in tech. The files and directories are shown here. To use Git for version control in our project, we first need to create a Git repository, often referred to as a repo. A repo is a directory consisting of two parts. The first is the files and subdirectories that we create and edit. In this case, a file called funding.doc, a report in Markdown file format, and a subdirectory called data. The second part is the extra information that Git records about the project's history. The combination of these two things is called a repository. The combination of these two things is called a repository. Git stores all of its extra information in a directory called .git, located in the repo's main directory. Git expects this information to be laid out in a particular way, so we should not edit or delete .git. There are many benefits to creating a Git repo, including the ability to systematically track the versions of files, to revert to previous versions, and to compare versions at different points in time. If we host our repo in the cloud, then it also enables easy collaboration with colleagues. To create a new Git repo for our project, we use the git init command in the terminal. Followed by the name of our project. Mental Health Workspace. When we run the git init command with the name we provided for the repo, Git creates a new repo within the directory we ran the command from. We can use cd to change into this new repo. We can use cd to change into this new repo. We can check that the Git repo has been initialized correctly by running the git status command. command. Success! The output confirms we have a Git repo and suggests that once we've created files, we can use the git add command to track them using Git. Now we know how to create a Git repo from scratch. Let's look at how to convert an existing project into a repo. Let's say we started working on the Mental Health in Tech project without first creating a new Git repo. We can convert the existing directory to a Git repo by executing git init without providing a directory name. We run the command from our project directory. The output confirms that an empty repo has been created and provides the location. Something interesting happens if we check the status of the repo. We can see Git has immediately recognized that there are modified files not being tracked by Git. In this case, the report.md file and files within the data subdirectory. The output encourages us to start tracking these files using Git. We'll discuss how to do this in the next video. One word of caution when creating Git repos. Unless we are working on a very complex project, we should generally avoid creating a Git repo inside another Git repo, also known as nested repos. If we do this, there will be two .git directories. Unfortunately, as we try to make commits, Git will get confused about which directory it needs to update. Time to make our own Git repos. We've set up our repo. In this video, we will build a workflow for updating and tracking our files using Git. We will build a workflow for updating and tracking our files using Git. There are 3 core steps to our Git workflow. First, we edit and save one or more files to our computer, as usual. Next, using Git, we add the file or files to a staging area. The staging area is created when we initialize a Git repository, and it keeps track of what has been modified. Lastly, to save the files using Git, we make a commit. When we make a commit, Git will take a snapshot of the files at that point in time. This is essential in allowing us to compare files at different points in time and, if necessary, revert to previous versions. We can think of adding files to the staging area as placing a letter in an envelope. By contrast, making a commit is like putting the envelope in a mailbox. We can add more things to the envelope or take things out as often as we want, but once we put it in the mailbox, we can't make further changes. So how do we track files using Git? Using the terminal, we can add a single file to the staging area using the command git add. Followed by the file name and extension. Here, we add our README Markdown file to the staging area. Alternatively, we can add all modified files in the current directory and any subdirectories using git add dot. As a dot represents all files and directories, in our current location. We then commit our draft file using git commit. We add the -m flag to allow us to include a log message about our commit, placing it in quotes. We include -m because it allows us to include a log message as part of the command. If we just wrote git commit, it would open a text editor, which we would need to add a message to, save the file, then exit to return to the terminal. The output shows one file was changed and includes a series of characters called a hash. We'll learn about commit hashes in the next chapter. The log message is important, as we can refer to it later. The best practice is to keep it concise. Now it's your turn to save files using Git. Welcome back. So, how can we see the version history of our files using Git? To do this, we need to understand how Git is storing data. Git stores data through commits, which have three parts: the commit itself, the tree, and blobs. Let's examine each of these components. The commit contains metadata, such as the author, log message, and commit time. The tree tracks the names and locations of files and directories when that commit happened. Think of it like a dictionary, with keys represented as unique identifiers mapping to files or directories. For each file in the tree, there is a blob, which means binary large object. A blob may contain data of any kind. Blobs contain a compressed snapshot of the file's contents when the commit happened. Here, we visualize 3 commits to our repo to see these 3 components. In the first commit, we see a unique identifier, hash. Reports.md shows a snapshot of what the files contained at tree, but only 2 were modified: mentalhealthsurvey.csv and a newly created summary statistics file. Therefore, the tree links reports.md commit and mental health survey to the tree. The summary statistics file wasn't changed, so the tree links to the blob in the second commit. Earlier, we mentioned a unique identifier called a hash. This is a 40-character string of numbers and letters, like this. It is called a hash because Git produces it using a pseudo-random number generator called a hash function. Hashes enable Git to share data efficiently between repos. If 2 files are the same, their hashes will be the same. Therefore, Git can tell what information needs to be saved in which location by comparing hashes rather than entire files. We can view commit information using the git log command, displaying all commits made to the repo in reverse chronological order, starting with the most recent commit. It will show the commit hash, author, date, and commit message. If the output doesn't fit in the terminal window, a colon will be at the end, indicating more commits. We can see more by pressing the spacebar. To exit the log, we can press Q and return to the terminal. Now let's use the commands we have learned to navigate the git commit structure. We've seen how to view the history of a repo. Now, let's examine how we can customize this to suit our needs. Git log is great, but the longer our project goes on, the more commits we will make, and the more difficult and time-consuming it will become to find what we are looking for. We have a few options for customizing the Git log output. We can restrict the number of commits displayed by including a dash followed by the number of commits. Here, we show the 3 most recent commits. Another option is to restrict the output to a specific file. Here, we include the file name report.md, which would restrict the output to the history of this file. We can even combine would restrict the output to the history of this file. We can even combine these two techniques. Here, we change into the data directory and display our CSV file's two most recent commits. We see both of these commits files two most recent commits. We see both of these commits added more data to the file. Another way to restrict the git log output is by date, adding the -- since equals flag followed recent commits. We see restrict the git log output is by date, adding the -- since equals flag followed by a date in single or double quotation marks shows only the commits since the specified date. We use the format of month, day, and year. Where month is a 3-letter abbreviation, day is 1 or 2 digits, and year is 4 digits. For example, to see commits since the 2nd of April 2024, we execute git log -- since equals 24. For example, to see commits and year is 4 digits. Equal to 2024. It's between the 2nd and 11th of April 2024 by including the filter on. The since and until flags are very flexible, such as 2 weeks ago. We can also provide a date using a numeric format, like 07152024. While various date formats can be used, we recommend following ISO format 6801, providing year, month, then day, separated by hyphens. We should also check our system settings to avoid unexpected results, such as 12/06/2024 being 6th December in written format, such as comp date. We need to see what changed in a specific commit on that day. We run git log and note the commit hash of interest. Generally, the first 8 to 10 characters of the hash are enough to be unique, so this is all we need. We can then use the git show command with a particular commit hash. The output displays the log entry for that particular commit hash. The output displays the log entry for that commit in the following bottom. In the Now it's time to compare versions of files at different points in time. In the last video, we saw the output of Git, how Git shows us the difference between versions. We can perform comparisons using the git diff command. Here, we compare the last committed version of our report with a modified version that is not in the staging area by running git diff report.md. The output shows two versions of the report, MD. The output by running git diff report.md. The output shows two versions of the report, version B symbols, and fives, and the plus and has 5 lines. This makes sense when we look at the next part of the output from the report. Red text that is not, which is not text start is now in the staging area. We can still compare it to the last committed version using git diff, but we need to add the -- staged flag. To indicate we want to look as previously, staged files versus their last committed versions. We can also compare versions between commits. We have two options for this. First, we can find the commit hashes of interest using git log. Then we can run git diff followed by the two commit hashes. Git will show what changed from the first commit to the second one. So, generally, we should put the most recent commit hash second. Alternatively, Git has a shortcut for us. The word head in capitals can be used to refer to the most recent commit. To look at older commits, we can reference them to head by using a tilde, then a number. So, to compare the second most recent commit with the latest commit, we replace the first hash with head ~1 and the second hash with head. ~1 equates to the last commit minus 1, so it represents one commit prior to the latest. The output shows version B, the version from the most recent, the commands and syntax that we discussed. Please use it for reference. We've learned several ways to compare files. Now, let's look at how to use git commands to resolve problems. Suppose we've modified a file, added it to the staging area, and made a commit. However, we've realized the last edit has a typo. We need to undo our most recent changes, restoring this file to the state before the last commit. To do this, we use the git revert command, which reinstates previous versions of files and creates a new commit with these older versions. Note that it will restore all files updated in that commit. We need to provide a reference through a commit hash or head to the changes that we want to undo. Referencing head means undoing changes made in the last commit, while adding -1 would undo or revert the second most recent commit. Let's run this and see what happens. By default, this opens a text editor where we are prompted to add a commit message. We can save and exit using these commands. Exiting, we can save and exit using these commands. exiting the text editor or files editor, opening. If we want to revert without making a commit at that point, allowing us to review and modify the changes before finalizing with a commit, we can include the -n flag, which is short for no commit. The git revert flag which is short for no commit. The git revert command only reverts a commit. It worked for us in this scenario. File is a versatile command, which, in this scenario, allows us to check out one or more files from a specific commit, again using the commit hash or head syntax. Here, we refer to the second most recent commit and narrow the command to a single file . We won't get an output, but we confirm by save the file's latest state. We now know how to make a new commit . To save the file's latest state commits. Update has been to unstage a single file. We can use the git restore command with the --. Staged flag, followed by the file name. This will move the file back to the working directory, allowing us to edit it before restaging and committing. Alternatively, to move all files in the staging area back to the repo, we execute git restore --. Staged . Without specifying any file names. We covered 3 new commands with several flags: git revert, git checkout, and git restore. This table summarizes their usage. Let's practice. Great job completing the course. Let's recap what you learned. In the first chapter, You discovered navigate the terminal start components in the blob and custom specific commit between different syntax and are made branches. You can learn about remote repos technique